Hi guys, welcome back to my channel, and this is the day 13 of DSA bootcamp. I will be starting with GFG portal as you can see on my screen, and I will be starting with the problem of the day. Today date was 20 July 2024, and the question is that removing half nodes, and this question was asked on Amazon only. Let's go to the problem itself. Here the problem states that basically, the first of all, the difficulty category is easy, and this question was asked in Amazon. You are given a binary tree, and you need to remove all of its half nodes, which have only one child, and return the root of the node of the modified tree after removing all of its half nodes. The output will be judged by an in-order traversal of a resultant tree inside the driver code. What it states that they will give you a binary tree and we need to remove all of its half nodes. Half nodes indicates whether the root consists of only either left child or right child, which indicate that is an half node. Here for this left subtree of 7 having a half node because of left child is present, right child is not there. So this is an half node. We can we can delete this node, remove our half nodes, and we can return this node, replace with 2, and we can return that. So it comes to here, and in order traversal will be 258. So that is the output as the question states that the output will be judged in order traversal. And same for here, there is no nothing half node because every node consists of two pairs, left and right child. And in order traversal will be 7 to 5. That's the output. And the expected time combination is linear, and auxiliary space will be head over binary. Constraints is given below. Sorry. Number of nodes will be ranges 1 to 10 power 5. Company types. And let's go to the notebook and let's understand the. Hope you got the question, and let's understand the approach how we are going to deal with and how we can solve that. Basically, we have to remove the node whenever the question states remove node in a binary, then we can simply think that if we follow any a binary traversal like in order, pre-order, post-order, we end up losing off some child nodes, leaf nodes, basically, if you follow in order and pre-order. If you follow post-order, which has in the pattern of going for the left child, going for the first, it will visit all the childrens, and then going to the nodes, like bottom-up approach. In that way, there is no losing of any child itself. All will be traversed, all will be identified, so that is the best approach you while dealing with removing any node in a binary tree. So same intuition we are following here, like using post order traversal, and in the post order traversal, we are visiting left subtree and then right subtree and then finally node itself. By doing this, we cannot skip any elements. We are visiting all of its nodes, and we can remove what are the nodes which consist of only one child. So we can remove that particular node itself. Okay, and here you can see while we are traversing, we will go to the child first, root, and if root again it goes to child. If the root is null, then we can return null itself. And here it comes to, and it goes to here because 7 consists of only one node, which is a half node. Then this 2 will be written, as you can see, root dot left will be written at the pointer of root at 7. So this will be replaced with 2. As you can see, this is the final trick which the interviewer was expecting for this problem. Let's go to the driver code. Here we are taking one data structure called node, which consists of data, store the original value, and having the left pointer and right pointer. While creating object, it will take the value, data value, and it will assign. And initially, it will be having left and right pointers will pointing to null. and this is the solution code. We have to remove all the nodes with only one child was present and return a new node. Note that root may change. What I said that here the root is there, and we are doing a recursion like a post order traversal by traversing all its left child, left subtree first, and then going to the right child, and after that it was dealing with the node itself. So this is the base condition. Whether any recursion problem, we have to handle the null check in the upfront as a base condition. We're checking root is equal to null, please return the null itself. No need to go for the further iteration. If it contains a root and it's having any left or right child component, please traverse to the left child, left subtree first and right subtree, as we are following post order traversal. Left subtree, right subtree, and then root. And check for the root whether it contains a leaf node or not by checking its children are none. If both the children are none, we can simply return that root itself. For here its case, the we are returning two. Here the left child is null and right child is null. So we are returning two itself, the node itself. So it goes to the above. So it goes to the above, and it will be stored here two instead of seven, because seven will be deleted as we are deleting half nodes, which consists of one child of left child or either left child or right child. So seven will be deleted and two will be replaced. And after that, we are checking for the condition. If the current node is a half node with the left child is null, then the right child is written and replaced with the given tray, which means that we are checking for the root node. If the root consists of left child is null, which means that we have a right child, so we can simply return that new root as a right child. Here in this case, we have only left child, so we can return left child as a root, and right child is null because of that. For that case, it will goes to here node, and it will check root node dot right is null. Yes, it was right. And node dot left consists of two, which will be stored in a new root, and that will be stored, and that will be replaced here. Seven will be replaced. So the final output will be written at the end node. And the same code is written in C++. You can take a screenshot of it, and Python, you can take a screenshot, and this is for JavaScript, who are working on JavaScript. And coming to the time complexity, we are traversing only one node at a time, so in a post order traversal manner. So it will be linear in nature, order of n, and this auxiliary space will be the height of the binary tree, and we are using recursion stack base. So in the worst case, if it contains any skewed trees, like having only the left child, either left childs or right childs, either it following like this or it following like this, then it indicates skewed trees. And in the worst case, it will be order of n, number of nodes, height will be 11. And after that, but in the average time complexity of a binary tree will be a log n, which indicates height, h height of a binary. That's all. Okay.